Okay, part 2 of our kinematics revision, quick revision as usual. Alright, previously we were doing speed time graph, so now we look at distance time graph. Okay, so for speed time graph, remember that the gradient gives you the acceleration. So for the distance time graph, what does the gradient give you? Speed, right? So you will think about gradient. You all like to remember as rise over run. So it's like distance over time. What is distance over time? Speed, right? So it's speed. So same thing again, remember we are going to use the 4 adjectives when we are going to describe distance or speed. Increasing, decreasing, constant, and zero. Alright? So as usual, look at the graph, the axis, distance, time. Okay, take note is distance, time. So when you solve, we are too used to thinking everything speed time, speed time. So when we see distance, time, we must mentally make a check and tell ourselves, okay, here the gradient is going to be speed. So you're asked again, right, describe the motion of, let's choose B, right, the motion of B. So if you describe motion of B, you do not just say, okay, the motion of B is increasing. We talk in terms of motion. In this case, we'll be describing in terms of distance and speed. So ask yourself, look at this, it's going this way, the distance is obviously increasing. Okay, so distance is increasing. Now, how about the speed? We look at the gradient. The gradient is, here is more steep and then getting less and less steep, less and less and less and less steep. So what is it? Its gradient is decreasing, the speed is decreasing, right? So the distance is increasing, but the speed is decreasing. So do this slowly, right? It's very easy to make mistakes, especially if the curve, right? We get confused. Oh, is it increasing or decreasing? So be careful. So this is decreasing, right? Constant will be this one, the straight line where the gradient is constant. Okay, same steepness all the way, then it's flat like this. What is it? Gradient is zero. Gradient is zero, speed is zero in this case. Alright, so just a flat line like that. And the distance is constant, right? There's no change, right? Whereas the gradient is zero, speed is zero. Okay, so I think you can do this. It's just a matter of being very careful with terms we use. It's always good to double check, okay, in case we make mistakes. Right, so the rest of it, that is mainly for science physics, the things you will focus upon. Okay, the definitions, the formula, acceleration formula, v minus u over t, the speed time graphs, the distance time graph, describe the motion of the graphs, okay, and all the calculations. So the rest of it is, a lot of it is just practice and practice and practice. So you should go through your notes again, look at what you have done, okay, the various things you have done, what you've done correctly and what you've done wrongly. Okay, so sometimes, for example, you know, this you find, oh, easy, very easy to do. Then when you calculate distance, take note about distance, right? The distance is not, okay, because we know it's area on the graph, right? Remember, it's not, don't use distance, use speed and sign, area on the graph. What you should do, okay, the approach, shade the area. So it's 14-20 seconds, you shade the area. So this is the area I want. So if this is the area I want, it is a what shape? Triangle. So it's half base times height, right? So half times 6 times 20. Okay, and the answer come out. Okay, do not write meter square. Okay, it's meters, right? So it's a good habit to shade the area that is required for the to calculate the distance. Okay, and they ask you for the whole 20 seconds, then you just shade the whole area. Okay, everywhere. Okay, so be very careful of that. Okay, so it's just practice, huh? So sometimes they ask to draw the graph, then you just follow again, as I told you, what is the approach, read the question, and then highlight important things like what? Initial speed is 1 meter per second. Then you know, okay, I don't start from 0, I start from 1. We are very fond to say, always start from 0, always start from 0. So it's from 1. And then what happens? Constant acceleration of 2 meters per second for 3 seconds. So it's going to go up 3 seconds. Acceleration is 2 meters per second. Right? So how do I know how to find the speed at 3 seconds? U say equals v minus u over t. Alright, this chapter you definitely you have to use this formula. And V, I remind you, is the final speed minus initial speed. Don't get it wrong way around. Huh? Then you find the final speed and then you draw a graph from there. Okay, so the graph, okay, would look something like this. Okay, it's a straight line. I don't have a ruler here, it's a straight line. So it looks like this. And then you're asked to calculate the distance traveled. Again, shade the area. Take note, take note, take note. Okay, I warn you, this is not just a triangle. It's a trapezium. Okay, you see, when you shade, okay, or you don't know what's a trapezium, then there's a little rectangle here and a bigger triangle here. Okay, so area of a small rectangle here plus the area of a big triangle. Okay, don't just say the distance is half base times height. This is a trapezium. So sometimes students forgot, okay, or they just shade the triangle area, but actually there's a trapezium shape. Okay, so be very careful about this. Alright, so take note about such questions. So it's always good to go through what you've done. Okay, see what you've done correctly, what mistakes you have made. Okay, so the rest of it, okay, when we come down to question like this, are slightly more tricky. Why? Because it's distance time. So once it's distance time, you see distance time, you write by the side of the question, gradient is speed. So it gives us a mental note. The gradient is the speed, right? And then you look, when we did this question, mark X on the graph, the point where the speed is greatest. Where's the speed greatest? Then you think, okay, if we think wrongly, we think speed time, we say, it's here, it's here, it's here. Okay, that's wrong, because this is distance time graph, it's not a speed time graph. So it's a distance time graph. If the speed is greatest, means what? The gradient is greatest. Where is the gradient greatest? Right, so you find the point. Where is the steepest point on this graph? Right, so the steepest point on this graph will be probably here, right? So at this time, the speed is greatest. All right, and where is the speed 0? Okay, when speed 0, gradient is 0. So, okay, where's the speed 0? Anywhere here, because it's flat. All right, so it's flat. So even something like this, some students can easily get it all wrong because they were thinking in terms of speed time graph. So it's very good, important, good habit to write down this first, that the gradient is speed. So we make a mental check to ourselves that this distance time graph, gradient is speed. Okay, if they give us speed time graph, then we write that gradient is acceleration. So that's a good thing to do. Okay, so the next thing is the O-level question. You see, they change the axis, time and distance. So you might be tempted to say, just say that in this case, the speed is increasing because the gradient is increasing. But because here's time, here's distance, the speed is decreasing, is the other way around. Okay, so be very careful. So other than that, okay, the definitions you must make sure you get correct. Okay, don't just say speed is distance moved per unit time while velocity is not. Okay, give two definitions fully and just write it down. Okay, so you have to learn your definitions. All right, very useful. So the rest of it, practice, go through things like this. Okay, go through yourself. Okay, should be able to do. Don't be careless. Then what happens to this when we get things a little bit odd? Curve. Then we ask ourselves again. Okay, what kind of graph is this? Okay, this is a speed time graph. Okay, speed time graph. Then we say, okay, the gradient is acceleration. Write down. So we make a mental note. Where's higher speed? Where's the highest speed? It's here, right? And from there, where's acceleration maximum? So gradient maximum. Where's the maximum gradient? Here, right? The steepest point. Where's acceleration 0? Right here, flat. Okay, where the gradient is 0. Where's the deceleration maximum? Over here. Where's decelerating coming down? Here's its steepest gradient. Okay, so as usual, I say write this down so that we make a mental note of what we are supposed to do. Okay, and as again, when we are asked to draw the graph, okay, again, I say again, the approach is highlight important information. Okay, highlight important information. Next step, okay, break it into parts, do it in parts. Okay, so they say from maybe do the first part first, from 0 to 4 seconds, then from 4 to 8 seconds or whatever it may be, or for another 6 seconds, that will be 4 to 10 seconds. So then do it by part, by part, by part. And every part, you check that you've drawn the shape of the graph correctly. and then make sure you label the correct values. Okay, don't draw everything and then forget to label. Okay, so you should be able to do this and then calculate the distance. What you should do, shade the area on the graph. Maybe it's a triangle, maybe it's a trapezium. Okay, but when you shade, it's less likely things will go wrong. Okay, so well, that's about it. It's just down what you should do. Okay, go through your notes. Then after you've gone through your notes, practice. Not practice yet. Go through your worksheets you've done. Okay, see how you've done things correctly or wrongly. Okay, make a mental note, and then after you go and practice some more. Okay, so other than that, you should be fine for this chapter.